Good evening, everybody. It's a real pleasure and an honor to be here amidst a lot of people I respect and a lot of friends. The previous talk by Christian actually set the stage for my talk today. As I mentioned, I work in the AI research lab, and day in and day out, the thing that keeps me awake is this disruptive trend that we're seeing with generative AI and how they can become foundational models for a broad ecosystem in AI. Am I audible now? Yeah. Okay. I actually don't need to mention it anymore, right? There are so many different ways. If you're doing programming, if you are trying to discover the protein folding, or if you are trying to figure out genomic analysis, or just want to do a lot of different things, and turn in your essays, or turn out a presentation, or create images. Generative AI is really kind of at the hype cycle right now. And this is real, and this is, as I love the example that Christian gave, and it gives us a lot of energy to be working in this area. But there is also a lot of hype, and there is and they're all exciting things. For example, this project called AutoGPT, which uses agents powered by generative AI to achieve things. And that project got some 120,000 GitHub stars in a very short time, which took PyTorch 5 years to achieve. But then, as we know, that with great power comes great responsibility. And if you want to apply AI in enterprises, then it still depends on the data that the models are learning from. So for example, one of my colleagues, Ted Dunning, pointed this out. I think you heard about this example of legal research which was done using ChatGPT, and it turned out a fictitious precedent case. And what was interesting is right after that, the different LLMs started to put in guardrails around that. And so if you ask this question with this guardrail, it gives a nice summary, and it was not generating any wrong information, but you change it slightly, and you just add limited at the end of the company name and ask that question, and it goes off and generates a lot of fictitious details, which is great when you're actually trying to write a story, but not great when you're trying to depend on it for legal work. In fact, I went and tried this again now, and I saw that if I give this query, then it still does the right thing. But if I again reword it a little bit, it again goes back to hallucinating. So the question is that trustworthiness of AI, what does it depend on? And this has been our work for a while, that it depends actually on both the data that is being fed to the models, as well as how the models are seeing the world of that data, as well as the pipeline that is between them. And so there are different levels at which you could tackle the problem of trustworthy AI. Now, the thing is that everybody wants to do the model work, and there's been this focus in the industry for a long time because models weren't that powerful, models weren't that good, and we had some benchmark data sets, and you keep optimizing against that. But now the models have become so good that it has become really important to focus on data. And it's important to have these benchmarks that allow you to figure out and to drive the industry to actually improve the data while keeping the model fixed. And that's the area of data-centric AI. So now what does that mean when we are talking of these shift and this huge paradigm shift that we're seeing? All of the examples, many of the examples I talked about in the first slide were all based on generative AI, or they were based on foundational models. So this change is shifting from, used to have that you would have create an AI application, you create a task-specific model. Just going back to the example that we saw, you would have actually figured out the data set that you want to train your model on, and you figured out what you want to do to model it, and you do it one task at a time. And of course, soon enough, that evolved so that you could do transfer learning, where you could actually, you say that I'm I have looked at lots of images, and so I've learned the representation of images. I've looked at lots of language text and learned a representation. So it's okay if I have trained on one task, but then I can fine-tune it for a different task, like doing sentiment analysis or question answering in an NLP. And there are typically two kinds of fine-tuning. One is with respect to the task, and sometimes with respect to the domain of the data. For example, you have images which are general images, but then you have added sketches to it. So then you do a domain adaptation, which is kind of adding layers or changing the layers in the front of the model. For tuning the task, you might changing the layers at the end of the model. But then you have this emergence of these foundational models, which are training once, and specifically the ones based on generative AI, are trained once on an enormous corpus. And what we observe is that as you train them on these huge models and trained on huge amounts of data, they start to have emergent adaptation properties. You do not even need to fine-tune them. You can ask these questions as part of your query to the model. GPT-4 and Stable Diffusion are examples of some of those, which many of you might have already played with. So now the thing is, what does it mean for this area of data-centric AI? So clearly, training foundational models incurs a huge cost, and this is actually the y-axis is in log scale, and this is showing the computational cost of from the pre-deep learning era to deep learning models, and then now to the foundational models era. And you can see that there's a huge growth in that computation since we're going to bigger and bigger models. But also what is interesting is if you look back in 2009, the top supercomputer in 2009, today, which is the equivalent of a 1 week of an accelerated server with GPUs, with 8 GPUs, that could have, was 1 million times more powerful than the model computation that was required. So you could train 1 million models on that supercomputer for 1 week. But today, if you look at it, if you look at the frontier supercomputer at Oak Ridge National Labs, you in 1 week, you can train one large foundational models. So, and not to mention the carbon footprint and all of those implications, there is a lot of effort to optimize these, but it's fair to expect that, people are not going to actually try and go and, not many people are going to be able to retrain these huge foundational models. But then when you have these larger models, you think that, okay, as you get larger and larger models and you train them with larger and larger amounts of data, it is unlocking very, very powerful capabilities. But then if you try to actually apply it in practice, as in the example that we saw, and many other examples, then you realize that there is a lot actually that happens behind the scene from the generation, which is really predicting in the case of language models, it is predicting the probability of the next word that you would utter based on the context of everything that you've said. And it's actually predicting a probability distribution about all possible words. And then you sample from that probability distribution because you always pick the probable word, then you're going to have very, very bland and non-creative outputs. But then if you want to really make it understand that this is a question I'm asking you, it may not understand that it's a question, right? It might generate more questions. So that's kind of where this context window, that the history that it learns from, can be tuned. And that's kind of called this area of in-context learning. And what I was saying was this, without even retraining the model, just by giving it examples of what you want it to do, it's then able to answer those kinds of questions. And so you have these few-shot, one-shot, and even zero-shot learning capabilities. However, that is often not enough. And so you need to go and actually, for example, give it some examples. And we can call this, from learn to imitate, which was the first step, to learn to follow instructions. So you give it examples, and this is effort intensive, so you need data to be able to, from human labelers, to give you good examples of the questions and kind of fine-tune the model with that. Now that also gets, too much to do, and so you say that some of the efforts are trying to do it, and this is what enabled ChatGPT, was this reinforcement learning with human feedback, where it now tries to actually look at comparative results that have been provided by humans and tries to predict how to reward the model if it gives a better answer, and then run the policy that will actually result in those better answers. So these 4 stages. These are examples. I gave this example with large language models, but you could see a lot of parallels also if you're looking at image generation and stable diffusion. There is some kind of a taming and tuning. You see there's a lot of, you can purchase prompts, for example, that will generate great images for you. So in each of these areas, however, you can see now the difference is not in the model, not so much in the model, not in this, it's at the most the size of the models, but the difference is in the data. So GPT-3 was out like 2 years before, before ChatGPT came out. And so it was that whole tuning and with good amount of data that really took, this enormous amount of time. So you can look at, if you're trying to train the model, you want to have diverse amount of data, huge amounts and broad, categories covered. And that, if you look at the effort, even back to the genome model that I was talking about, if you look at the curation process just to get the training data, it's huge and intensive. But then, if you actually want to apply this to your use case, there is this challenge of, how do you supply these carefully designed prompts, this trial and error process. And every time you do that, it's going through these huge models. So, 175 billion parameters or 500 billion parameters, and it's actually, sprinkling through all of that. And so there's a huge inference cost, which of course is constantly getting optimized. But then, so you say that, okay, instead of that, maybe if we are, when we are supplying these data that allows you to learn to follow, you again need a lot of intensive curated information. And then you say that, okay, if you want to learn to steer, comparing two things is much easier than actually generating a full answer or supplying fully labeled answers. And so you can have maybe 10,000 to 1 million kind of words. And these ones are a lot less costlier than that initial pre-training. And so the AI landscape is now shifting to a new ecosystem of possibilities. So at the top, you can see that there is this model design or these model pre-training, which really is in the purview of a few AI elites. Maybe somebody wants to do a scientific, huge scientific foundational model. They might want to play with that. But then the bulk of the opportunity is really further down. So, we used to have this notion of producers of AI models and users of AI models. Now we have this category in between, which you can call them prosumers or model prosumers, because they produce kind of models, but they are consuming an existing model and specializing it. And at the bottom, of course, there's a broad base of many, many creative applications. But this middle area is really where there's a big opportunity for innovation and specialization, especially when it comes to trusted AI. And just to give a feel, I know there are sessions on generative AI tomorrow, so that's going to go into, and large language models tomorrow, that's going to go into a lot of depth. But just to give you a feel of this whole question, of impact of asking the right questions. If you tell them, this idea of chain of thought prompting, so that if you actually ask the question by telling the model how you reasoned, then it's able to generate better answers. But surprisingly, sometimes if you tell it, let us think step by step, it does a better job. If you say, let us work this out step by step to make sure you have the right answer, it does an even better job. And what you can see here, these graphs here, which are really showing that these kinds of improved prompting are now catching up with what you can get with fine-tuning. But as you can see, the fine-tuning, the supervised fine-tuning still has better performance. And of course, doing these iterations of prompt tuning and is costly in terms of inference. And sometimes what happens is if your model doesn't have any awareness of that concept, then you can get into these hallucination examples. So supervised fine-tuning kind of helps with this, and so this is just an example of giving it lots of question-answer pairs. But you have to be careful here, because sometimes these concepts are, if when fine-tuning, you're giving it examples which the model didn't have a broad representation about, it can get it wrong. It can become brittle when you try to apply it in a slightly very different scenario. So you can address this problem by trying to train these LLMs with domain-specific fine-tuning. So maybe if it's a medical domain or a legal domain, then you first train it with and fine-tune it with unlabeled data, and then you kind of go and do instruction-specific fine-tuning, and then you can do task-specific fine-tuning. So these are just some of the things that you could do. Now, each of these stages gives us an opportunity now to go back to that original question. So each of these stages is a data-centric process, and each of these stages, there are lots of techniques that are waiting to be developed, and several very exciting techniques that people are working on. So this is actually just an example from the trustworthy AI principles that we have at HPE. Most companies have their own version of trustworthy and responsible AI principles. And there are really three aspects. So there is, for us, we are looking at how do you have a foundation, or what we call a data foundation, that allows you to capture these kinds of metrics and how the trajectory is actually behaving so that you can optimize that. And techniques to be able to assess and understand trustworthiness, and then techniques to fine-tune and synthesize models. So how does that work a little bit differently in this world? So for example, you would want to have, in addition to this metadata tracking frameworks that we have, there is this notion of ecosystem graphs of how these downstream models are connected and what's the impact there. There is these techniques, people are starting to use AI. In fact, you can use AI to optimize AI data, or you can start to use AI to actually improve itself. Very interesting papers like reflection, which is saying that can I ask the AI model to reflect? It is somehow able to tell whether it's doing the right thing or not. I can ask the AI model to self-align and to principles that we want it to be, to actually adhere to. And there is always a tension whenever we are doing this, like whenever we're trying to tame these models, there is a tension back between the creative aspects or the diversity of things that it can come up with versus having it be trustworthy. And of course, there is all this effort on watermarking, so that because very soon maybe the internet is going to be flooded with AI-generated content, so you want those things to be watermarked so they are not being used to feed AI models from then on. So that concludes my talk. So I believe that for enterprises, to make the most of this disruption, call to action is, and I'm a member of the LFAI Trusted AI Committee, a call to action is to kind of come, to see if we can come together and accelerate this effort so that we can use, AI, the full power of these AI foundational models. It's never going to be like an operating system like the Linux kernel that I worked on, which was a foundational model of, this is a foundational model of a very, very different category, and it requires a very, very different way of leveraging and making benefits of it. But there's exciting times ahead. Thank you.